You wouldn't spend your entire afternoon getting up from your desk every 5 seconds.
Oh, definitely not.
Walking over to your window, checking the empty front porch for a package, and then just sitting back down.
No, I mean, that sounds incredibly exhausting.
It's a terrible way to live.
Yeah, completely.
Yet for years, developers have been forcing your web browser to do exactly that.
Right.
Just burning through system resources just to see if, like, a single element has finally loaded on a page.
Which is wild when you think about it.
It really is. So, welcome to today's deep dive. We are looking at a brilliant piece from the tech-reader blog.
Yeah, by Aaron Rose.
Exactly. It's titled The Secret Life of JavaScript, the Mutation.
And, Aaron's piece is just a standout. It really is, because it takes this fundamental architectural shift in front-end development and, well, it grounds it in a highly relatable engineering nightmare.
Oh, for sure.
It explores the kind of high-pressure, problem-solving scenario that literally any developer has sweated through at like 4 in the afternoon on a Friday.
The absolute worst time to get a new requirement.
Oh, worst.
So our mission for this deep dive is to really uncover that massive shift in how modern browsers handle changes behind the scenes. We're looking at how the industry is moving away from those resource-draining polling hacks.
Right, the old way.
And moving toward this elegant, silent system of observation. Okay, let's unpack this by dropping right into the frustrating workplace dynamic that Aaron Rose uses to set the stage.
Yeah, so we meet Timothy. He's this front-end developer who is suddenly dealing with a mandate from his marketing team.
Poor guy.
Right. And he's got his mentor, Margaret, who, well, she seems to run entirely on her signature dark roast coffee.
The developer fuel.
Exactly. So marketing has demanded the immediate integration of this massive black box third-party chat widget into the company's main application.
Ugh. I mean, those third-party vendor scripts are notorious for a reason.
Oh, absolutely.
They load completely asynchronously. They fetch their own massive payload of dependencies on their own schedule.
Right, they don't care about your site's performance.
Not at all.
Okay.
And then they eventually inject their user interface directly into the DOM just whenever they feel like it.
Whenever they feel like it, yeah. And Timothy has been tasked with attaching a custom analytics tracking event to the vendor's specific Chat Now button.
Okay, so he needs to track when users click it.
Right. But since he doesn't control the vendor's source code, and of course they neglected to provide a ready callback or like a custom event to hook into.
Oh, they never provide those.
Never. So he is flying blind. He has no native way of knowing when that specific node is actually appended to the document tree.
Right. And I mean, when backed into a corner by a product requirement like that, the instinct is usually to reach for a brute force set interval loop.
It's the classic panic move.
Yeah. Timothy writes a script that continuously queries the DOM every 100 milliseconds, just searching for the button's ID.
Over and over.
It's like a kid in the back seat of a car constantly asking, "Are we there yet? Are we there yet?" Every single fraction of a second.
That is the perfect way to describe it.
Totally distracting the driver from the road.
Yeah, and Margaret actually catches this during a code review. And she offers an even sharper analogy to illustrate the architectural flaw here.
What is she saying?
She tells Timothy he has essentially hired a night watchman.
Okay.
But instead of giving him like a bank of security monitors to watch, he's ordered him to sprint down a long hallway, throw open a door, visually scan an entire room, and sprint back to his desk 10 times a second.
Wow. I mean, that's...
It's absurd.
Right. But I want to play devil's advocate here for a moment.
Sure.
Because Timothy offers a defense in the text that I think a lot of developers have leaned on at some point.
Oh, I've definitely used this defense.
Right. He argues, but wait, it works. The loop clears as soon as document.getElementById finds the button.
Technically true.
Right. If the clear interval fires and the analytics attach successfully, the job is technically done. I mean, modern processors are chewing through billions of operations a second. Surely a simple DOM query running 10 times a second is just a drop in the ocean, right?
Well, Margaret completely dismantles that defense.
Does she?
Oh, yeah. By looking really closely at the execution context. See, every time Timothy's loop fires, it isn't just a cheap memory lookup.
Okay.
It forces the browser to actively traverse the DOM tree.
Ah, wait.
And if the user happens to be on, let's say, a choked network connection, like a slow 3G mobile network.
Which happens all the time.
Exactly. And that asynchronous script takes 3 full seconds to parse and execute. Well, Timothy's hack just forced the browser's main thread to execute 30 useless synchronous queries.
Wow. And since JavaScript is single-threaded,
Exactly.
that single-lane highway is getting completely clogged.
Locked up.
Right. Every
Yep.
time that night watchman sprints down the hall, everything else the browser needs to do has to yield.
Yep. Parsing CSOM, handling garbage collection.
Registering touch events.
Right. Calculating layout geometries. It all gets queued up behind this totally useless blocking polling operation.
That sounds like a nightmare for performance.
What's fascinating here is that this specific anti-pattern is a primary culprit behind layout thrashing.
Really? Just from polling?
Yeah. When you force the browser to constantly evaluate the DOM structure, you interrupt its highly optimized rendering cycle.
Okay, that makes sense.
It's the exact reason you might be scrolling through a dense article, right?
Yeah.
And the screen suddenly stutters.
They hate when that happens.
Or an animation drops frames entirely. It's usually this kind of polling.
And this isn't just theoretical drama for engineers, you know?
Not at all.
Like, for you listening, when your phone suddenly feels physically hot in your hand while reading a seemingly simple web page,
Yep.
or your battery drops 10% in 5 minutes.
That's the one.
That's the CPU spinning up, burning through energy just to execute these synchronous loops, asking a question that hasn't changed.
Exactly.
The site isn't necessarily doing too much. It's just asking the same useless question way too frantically.
And the hidden cost is staggering when you scale that across a complex web application.
Oh, I can imagine.
If every third-party integration or lazy loaded component relies on continuous polling to check its state,
Your app is dead on arrival.
your performance budget just evaporates before the user even interacts with the page.
So we've firmly established that forcing a watchman to sprint down the hall 10 times a second is a disastrous architectural pattern.
Total anti-pattern, yeah.
Here's where it gets really interesting. Because Margaret steps up to the whiteboard to map out a radically different approach
Thank goodness.
using the Mutation Observer API.
And this is where we see the massive paradigm shift in the platform itself.
Okay, tell me about that.
Well, prior to this, developers relied heavily on JavaScript doing all the active labor of traversing and checking.
Right, the manual polling.
But Margaret's whiteboard diagram separates the JavaScript runtime environment from the browser's underlying C++ core engine.
Oh, like the Blink or WebKit engine.
Exactly. The actual engine that is constructing and rendering the page.
And that distinction is crucial, isn't it?
Huge.
Because with Mutation Observer, we aren't writing JavaScript to manually check the DOM tree anymore.
Yeah.
We are handing the surveillance mandate entirely over to the C++ engine.
Yes. We are officially firing the exhausted night watchman.
Let them rest.
And we're installing Margaret's new analogy, which is a silent security camera.
I love that. A silent security camera.
Right, because the C++ engine already knows exactly when the DOM changes.
Because it's the one making the changes.
Precisely. It's the very entity parsing the incoming nodes and constructing the tree. It doesn't need to query anything. It fundamentally is the environment.
That is so elegant. Because that security camera sits passively at the lowest architectural level. The main thread gets to completely power down its polling operations.
It can actually do its real job.
Right. It can focus on actually painting pixels and handling user inputs without being constantly hijacked.
And the mechanism of how it elutes the system is really clever, too. It relies on the browser's event loop, specifically the microtask queue.
The microtask queue. Okay.
So when that bloated third-party script finally finishes executing and appends the Chat Now button...
Whenever that might be.
Right. The C++ engine structurally updates the DOM tree, and instantly it detects the mutation it was configured to watch for.
So it doesn't just interrupt the execution stack randomly?
No. It packages that mutation record and neatly pushes it into the microtask queue.
Oh, that's polite.
It is. It effectively taps our JavaScript on the shoulder to wake it up, but only the exact moment the current synchronous execution context finishes.
So it guarantees the callback fires asynchronously,
Right.
but before the browser's next repaint.
Exactly. You completely avoid the macro task delays that you'd get with set timeout or set interval.
So the UI updates seamlessly.
Yep. 0 wasted CPU cycles checking an empty room, and 0 layout thrashing.
Okay, so a silent security camera hooked directly into the C++ engine's microtask queue sounds like an absolute silver bullet.
It really does.
But, if you mount a security camera on the Empire State Building and tell it to alert you every time a car moves...
Oh, you're going to crash your system immediately.
Right. You'll be overwhelmed. The implementation details are where this either saves your application or completely tanks it.
Which is why Margaret spends the rest of the mentoring session diving into the configuration object.
For the parameters you pass to the observer.
Right, to avoid creating new bottlenecks. And the first pitfall she highlights is scope.
Scope.
Yeah, the immediate temptation for a lot of developers is to just attach the observer to the document.body and set the subtree parameter to true.
Just to make sure they don't miss anything.
Exactly.
But that means your JavaScript gets tapped on the shoulder when an ad carousel rotates.
Yep.
Or when a lazy loaded image swaps its source attribute.
Or when a user types a character into an entirely unrelated search box.
Oh my God. You've essentially recreated the performance nightmare of polling.
Yes, just through a different API, because your callback is now executing thousands of times a minute.
So how do you fix that?
Well, to prevent that avalanche of mutation records, the observer must be scoped to the absolute smallest DOM node possible.
Keep the focus narrow.
Right. Since Timothy knows the marketing widget injects its payload into a specific wrapper, they attach the observer strictly to that single hash chat container element.
Isolating it from the noise of the rest of the application.
Exactly.
That handles the spatial footprint. But the API isn't just like a blunt instrument for detecting new structural elements, is it?
Not at all. Margaret goes over the configuration parameters, and it turns out you can be incredibly surgical with what constitutes a valid trigger.
Like what? What else can it watch?
You can instruct the C++ engine to ignore structural additions entirely and only wake up the JavaScript if a specific HTML attribute changes.
Really? So if you only care about an element toggling from a disabled to enabled state.
You just use the attribute's Boolean.
That's amazing.
Or, say you're building a collaborative rich text editor, you can track raw text node modifications with character data.
So you're basically building a highly specific filter. So the microtask queue only receives the exact payload you actually care about processing.
Precisely. You only get alerted when something relevant happens.
But even a perfectly scoped, highly specific observer becomes a massive liability if you ignore Margaret's final and arguably most critical lesson.
The memory management.
Right?
She physically taps the screen to emphasize this point in the text.
It's that important.
It is,
Yeah.
because once the Chat Now button is detected and the analytics event listener is successfully attached, the observer's purpose is completely fulfilled.
It's done its job.
Yes. And failing to call the disconnect method leaves that observer silently running in the background for the entire life cycle of the page.
Oh, wow. And this is a major issue in single-page applications especially, right?
Oh, it's brutal. It becomes a silent memory leak.
Because the browser's garbage collector can't clean up the observer or the closure it references.
Exactly. The C++ engine still holds an active reference to it, dutifully watching a container for a button that has already been processed.
Just burning memory for no reason.
Yeah, so calling disconnect explicitly severs that tie. It tells the engine to power down the camera, release the references, and free up that memory allocation back to the user's device.
That is so important.
Yeah.
And the resolution Aaron Rose writes for this scenario is incredibly satisfying.
Oh, it's a great payoff.
Timothy rips out his hacky set interval loop. He implements the scoped, specific, cleanly disconnected observer pattern.
We're right way to do it.
And they run the performance profiler
Yeah.
and the CPU graph, which previously looked like a jagged saw blade of synchronous queries.
Right.
It stays completely flat.
Beautiful.
A few seconds later, the chat widget resolves, the microtask fires exactly once, the analytics attach, and the observer just disappears into the ether.
It's perfect.
So what does this all mean?
Well, Margaret frames this technical victory as Timothy unlocking the final piece of what she calls the observer trilogy.
The trilogy.
Yeah, because modern web development has fundamentally shifted away from imperative brute force measurement.
Toward a declarative, highly optimized surveillance toolkit.
Exactly. She's talking about how we used to bind heavy listeners to scroll events, right? Just to check if an element was visible.
Oh yeah, firing calculations thousands of times a second just by scrolling down a page.
Nightmare for performance. Now, we use Intersection Observer to let the engine handle viewport intersections natively.
And we used to listen for raw window resize events to recalculate component widths.
Which caused massive layout recalculation.
Yes, but now Resize Observer handles dimensional changes seamlessly at the individual element level.
Right, and now the Mutation Observer completes that trifecta for structural DOM changes.
It really is a testament to the maturity of web standards, isn't it?
It absolutely is. The platform itself has evolved to take the heavy lifting away from the JavaScript execution context, and it just hands it to the underlying architecture where it belongs.
And The ultimate beneficiary of this architectural maturity isn't just the developer looking at a cleaner code base.
Oh, definitely not.
It's the user.
Yeah, it's you. You get a responsive interface, smooth scrolling.
And a device that doesn't sound like a jet engine spinning up just to load a blog post.
Exactly. Behind the scenes, millions of those exhausted night watchmen have been retired.
Finally.
Leaving us with a faster, cooler, and more battery-efficient web.
I love that. So we've spent this deep dive looking at how our digital tools have evolved from exhaustively, blindly polling for information, right, into this sleek system that quietly observes and only acts when truly necessary. So I want you to think about your own routine.
That's a good question.
Where else in your daily life are you still utilizing the night watchman approach?
Yeah.
Are you manually refreshing your inbox every 10 minutes, hoping a specific email has finally arrived?
I'm definitely guilty of that.
Right. Or are you compulsively checking your analytics dashboards or opening your bank app constantly to see if a deposit cleared?
Just burning your own energy.
Exactly. Where are you exhausting your own mental main thread? By frantically checking an empty front porch, when you could be building a better system to simply alert you when the package has actually arrived.
That is a really great way to look at it.
Thanks for joining us on this deep dive. We'll catch you next time.